Good morning. So today we'll discuss about the mechanical estimation. Mechanical estimation. So if I want to find out the cost of any process, mechanical process, first I need to know how much time it required to complete the job. So in order to have the know how much time is required to complete a particular job, I need to have the machining time. So estimation of machining time is very much important. Estimation of machining time. So how to find out the machining time? So we know that if I have the cutting speed is given, say cutting speed is given as S is the cutting speed, which is given in meters per minute, and D is the diameter of the job, and say N is the revolution of the tool, job per minute. And say if I have taken the feed is per revolution, then how to calculate this cutting time or machining time? So how much time is required to complete a job? So we know that cutting speed, which is equal to S is equal to pi dn by 100, which is in terms of meters per minute. I'm talking about meters per minute, not mm per minute. If it is mm per minute, we can change into n by. Now, see if n is equal to, then from this I can write n is equal to 100 into S divided by pi. So which is, you can get it in the form of revolutions per minute. So if I want to get the feed, this feed, which is in terms of feed per revolution, so if I want to get feed per minute, then RPM, revolution per minute, into the feed per revolution. If I give feed per revolution, then I'll be getting in terms of feed per minute. So RPM is N into feed per revolution as given as F. Okay, so from this I can use the machining time calculus, which I have done already in the MCW, the metal cutting. We have studied all this. So then machining time, which can be taken as length of cut, I can say length of cut divided by feed per minute, or we can say directly L by F into N, because if you substitute directly, this feed has to be substituted in feed per revolution. If it is given feed per minute, then straight away I can take the length of cut by feed per minute. So this equation I can be used. So by using this machining time, I can evaluate the total time completed for the job, and as well as if I take the approach and overrun into consideration, so then T will be taken as length of approach and length of overrun divided by F into N. So this will give the machining time. In terms of minutes. So this is how we can find out the. Of course, we have the machine shop and welding shop, so we can have the different where we can work with. Then we can find the mechanical estimation of each job, how much time it is required. Then based on that, we can find out the cost of the material. So if you take generally this facing knurling and lathe machine, facing knurling and all those. So we have the machining time is same, that is L by Fn, and the length of cut will be keep changing. That is the length of cut, how much you are going to do for facing, and how much you are going to do for the turning, and how much you are going to do for the chamfering, drilling, and all those. We can have the same kind of equation. Okay, so here we can use the even boring, counter boring, reaming, all the different operations which you have. So based on that operations, we can find out the what is the machining time required for a completion of one job. So based on that, we can use one problem of calculating how you are going to calculate the machining time for a job, for a particular job. Okay, so here a simple job I'm going to take here, a simple job I'm going to take here. See here, this is the raw material which I'm going to give to you. So producing a job, producing a job. So then this is the right. So now I have got, this is the piece which has to be made from the cylindrical surface, which you need to produce a step turning component from the given job. So this is the thing which we need to, so this is the actual job which is given to you, and we need to reduce this job to given dimension. So if you take this, like this, okay, I'll give the dimensions of this. So dimensions of this is given as this blank which is given to you is the diameter of 30, and the length of this component which you are going to make, say this is up to here, then up to here, and then you can take this as a 3 dimensions. One is, this is 30, sorry, 20. Of course, all dimensions are in mm. Then 20. Then this diameter is going to be 20. And this small diameter is going to be, this is going to be 30. This is going to be 30. You can take it as, okay, this is 30 and this is going to be 20. And take it as 20. Okay. So this is the component which is given. We need to find out the how much time taken to prepare a job. So how much time to, how much
given blank is also 30 now, sir.
Isn't 30? Oh, sorry, then it will be 50. Then it will be 50, sorry. This will be 50. Yeah. 50, okay. Right. So then how much time is taken? How much time is taken to complete this job? I mean, you need to prepare this kind of step turning model. So actual job is given. So from this, we need to find out how much time is going to be taken to complete this model. How much time taken to prepare the job, okay. So here this is given as 60. Of course, these are all in, okay, if you take in mm, you can take into mm, and then, and so this is the 60 mm piece. Length of the piece is going to be 60 mm, and the diameter of the blank is given as 50 mm. So based on that, we need to assume the data given as cutting speed for turning, is given as 20 meters per minute. 20 meters per minute. So in this blank, he is going for boring count, not like, from this piece is not producing. This is the piece actually is like that only. It's like that only. Okay. So from this, we are going to find out the how much is going to be time taken for drilling and boring also. So for turning and boring, it is taken as 20 meters per minute, and for drilling, cutting speed for drilling is given as 30 meters per minute, and feed for turning and boring, and boring is given as 0.2 mm per revolution. So here F is given mm per revolution, and then feed for drilling operation is given as, assuming this data, feed for drilling feed for drilling is given as 0.23 mm per revolution. So this is the data, and also depth of cut not to exceed 3 mm. Depth of cut not ex depth of cut not to exceed 3 mm. So based on this given data, we need to find out how much time is required. How much time is required to complete the job. So we have taken that the diameter of the given bar is taken as, say for example, 55. If I take the 55 as the bar diameter, so the bar actually given bar or blank, which is, say for example, actually we need to get the 50 mm, so I'm taking 5 mm extra, and then 55 mm is the actual bar is given, means we need to reduce the 5 mm to get the given dimension. That is, the dimension is given as, say, 50 mm, right? So this is the additional material which we need to remove this. So this is the thing which I have, say for example, this is the given as 55. This is given as 55. So we need to undergo the turning to reduce to the 50. So that is why the blank diameter is taken as 55. So straight away we cannot get 50 mm. So 55 we need to reduce to 50 mm. So first it has to be reduced go to 50 mm by turning operation. In a single cut, we take the depth of cut as 3 mm. So depth of cut as 3 mm. So we can take the diameter is going to be given, the blank diameter is going to be 50 mm. So I can take it as 5 centimeter. I can take it as 5 centimeter. And speed, we have taken the cut. Turning and boring is given as 20 meters per minute, because first cut we are taking. So that is to reduce the diameter from 55 to 50, and the feed is assumed as 0.2 mm per revolution for turning as well as boring. That is what here feed is 0.2 mm per revolution. So now the cutting speed N1 we can find out by using this 100 into S1 divided by pi into D1. So here this is 100 into S1. S1 is given as 20 meters per minute. So 100 into 20 meters per minute. So pi into D1 has to be converted into meters. That is 0.05 meters. So here if I calculate how much I'm going to get, 5 by 100 will be in 5 4 ja, then how much it is going to be, N1 RPM. Then we need to find out the T1, that is length of cut, that is the turning how much you are going to do, because it is a 60 mm. So I'll take it as 6 centimeter. Length of cut divided by feed per revolution into RPM. So that is length of cut is 6 centimeters, and then feed per revolution is given as which is given as 0.02 into 182. So it is 0.2. Sorry, feed per revolution is given as 0.2, not 0.02. So into this RPM, how much you are going to get, that you have to substitute here. Yeah. So this is the N value. This is the N value which you are going to get. So this N, whatever how much you get, that you need to substitute here. Okay. Then that is the T1. Next, the second step is what? Once you have done the 55 to 50 mm, then we need to drill a hole of diameter which is a length of 40, because first we need to take the small diameter to drill it, the whole component. See, if you look at this, So this is the diameter of 20 mm. So we need to drill first with this 20 mm. 20 mm to the depth of 40 mm length, to the depth of 40 mm length. So we need to drill a hole. We need to drill a hole of 2 centimeter, for the length of 40 mm, for the length of 40 mm. So what is the drilling length? See, time for cutting the drilling drilling operation. So length, how much length we need to be drilled, divided by feet per revolution into rpm. So that is, we know that speed per revolution for drilling operation we have taken as 30 meters per minute. So length of the drill, we know that it is a 40 mm, so will be taken as 4 centimeter, or we can take the 0.04 meter, divided by feet per revolution, which is given as for this one, drilling, it is 0.23. It is 0.23. So 0.23 0.23 mm per revolution. So it has to be converted into meters per revolution. So we can take it into meters per revolution. So into revolutions per minute. So here it is taken as in terms of meters. So this speed also should be in terms of meters. So 0.23 mm. So we can convert into divided by 1000. So we can take it as into n. N is the RPM which you have obtained. For this is going to be is different. So drilling operation we need to find out, that is N2 is equal to, because 100 into S2 divided by pi into D2. So here 100 into S, cutting speed for the drilling which I have taken as 30 meters per minute, and pi into diameter of the hole which is made in, which you are going to made is 2 centimeters. So D2 is 2 centimeters. So I am going to convert this into 0.02 meter, so that we can get in terms of revolutions per minute. So if we cancel out this, that is going to be, we are going to get the N2 value. So this N2 value in terms of RPM to be substituted, this N2 value should be substituted here. Okay. So and get the T2 So T2 in terms of minute. So likewise we are going to get the this is the second step we are going to do. That is, first we have done the turning operation. We have done the turning operation. So this job is required 3 operations. One is turning operation, second one is drilling operation, and third one is enlarging the drilled hole. That is, you can say boring. So enlarging the hole to the given diameter of 30. Say for example, so here these are the 3 operations we have to carry out. So here I have already taken turning and drilling. Then third step is this portion I have to do. So enlarging the hole from the 20 to 30, So that we are going to do here in the step 3. So these are 3 step by step. We are going to calculate the, for each operation we have to calculate the machining time. Then afterwards we have to submit all the 3 machining times, so that we will get the total machining time to complete the job. Now we take the that is enlarging the hole from 20 mm to 30 mm. For how much length? That is for length of 20 mm. For length of 20 mm we have to enlarge the hole. So here we need to find out the speed. N3 is equal to, because it is a boring. So it is enlarging the hole. Already drilled hole is called as a boring operation. So he has given that the speed for turning and boring is given as 20 meters per minute. In the data he has given as the cutting speed for turning and boring. He has given, see, cutting speed for turning and boring is given as 20 meter per minute. So the speed, the revolutions, if you want to find out the number of revolutions, RPMs, if I want to find out, then I have to use the N3 is equal to 100 into speed divided by pi into d3. So d3 you have to take. Now if you look at here, the speed is given as 20 meters per minute, and pi into d3 is, we are going to enlarging the hole from 20 20 mm to 25 mm, 20 mm to 20 mm to 30 mm, 20 mm to 30 mm. So totally it is enlarging the hole for 30 mm. So 0.3 when I convert into meters. So then you are going to get the speed. You are going to get the speed in terms of RPM. So once you get the speed, then the machining time can be calculated as length of boring divided by speed per revolution into speed into RPM. So here length of the boring we have taken as 20 mm, so 2 centimeter. Speed per revolution is given as for the drilling, for turning and boring it is same part, that is 0.2 by 1000. This is meters, meters per revolution. So here also if I convert this 20 mm meters, so 0.2 meters into, then we have taken this speed of the given N3 you have to find out and then substitute here, so that you will get in terms of minutes. So now we have calculated the what are the operations involved in making a job. So here there are 3 operations. So first operation is turning. So that is which you have calculating, that is the machining time required for turning is T1. Then we have gone for the drilling. So drilling, how much time it is required for drilling the hole is going to be taken as T2. And third one is boring, enlarging the already drilled hole. That is how much machining time is required for the drilled hole. So that is T1, T2, T3. Now I can calculate the total machining time. Total machining time is equal to T1 plus T2 plus T3. T1 plus T2 plus T3. So put together, I'll be getting in terms of minutes. Okay. So this is the estimation of time. Suppose if I have given the material cost of everything and done, say for example, we take one more example on this. Say I have a component. Which is like this. Say for example, this is the bar which is given as, this is the cylindrical bar which is given. From this bar we need to make a component like, say for example, it is given as step turning model. Okay. So like this I have to prepare. Okay, so this is the model which I have to, and this is the thing which you need to remove off. So now if you take the blank diameter is given as, this is a 35, diameter of 35, and this diameter is given as, say this diameter is given as 15, diameter of 15, and this is given as diameter of 30, and length of this is given as, say 20, and this is given as 60, and this is given as, say 20. Okay, and we have taken this mild steel. We are going to make the component like this. We are going to make the component like this for 100 pieces. We are making the 100 pieces, and the density is given as, density of the material is given as 8 grams per cc. 8 grams per cc is given. So material cost is given as, say, 8 rupees per kg. 8 rupees per kg. So then, if you take the parting off and facing allowances, parting off and as well as facing allowances. So if I make the parting off and facing allowances of per piece, parting off and some facing allowances. Facing allowances will be taken. Allowances will be taken as 1 centimeter, and cost of machining. Cost of machining is taken as 20 paise. 20 paise. And overhead charges is taken as, in terms of labor cost is taken, in terms of labor cost it will be taken. Overhead charges is taken as 50% of labor cost. 50% of labor cost. So from this piece we need to make, length of the we need to take as, say for example, this is the facing allowance which you are going to take as parting of allowance. We can take it as 1. Parting allowance is going to be taken as 1 centimeter. So total length of the bar we can take it as of now, that is total bar, this length, if we take it as, which is required 1 centimeter for parting, so we can take it as required per piece. So this is a piece which I want to make. So that is, I have taken as 6 plus 6 centimeter plus 2 centimeter plus 2 centimeter plus allowance, which is taken as 1 centimeter. So put together I'll be getting 11 centimeter. Then based on this total length of, then what is the volume required, because we need to find out the each component how much is going to be cost. So volume of the material required, volume of the material required is going to be, we need to find out the for each, means for this piece we can take it as pi d square by L. So this is total bar. Total bar is going to be, it will be taken as 35 as the diameter. So it is cylindrical diameter. So we can take it as pi r square h, or pi d square by 4. Pi d square by 4 into h. D is 3.5 into h, length of this bar, which is taken as 11 centimeters. So you'll be getting in terms of centimeter cube. So roughly around we are going to get 106 centimeter cube. Now the total weight of the material, if I want to find out, because if I want to make a one component, weight of the material required, is going to be density into this. So 106 into the volume into density. Density is given in 8 grams per cc. So divided by 1000 will be given in terms of kg. So I'll be getting 0.848 kgs. So material cost, if I because the cost of the material is given as 8 rupees per kg, 8 rupees per kg. So the cost of the material cost per piece is equal to this. We can take it as 0.848 into 8 rupees per kg. So that is rupees 6.784 is the material cost one piece. Material cost for one piece. Now we are going to calculate the machining cost. We are going to calculate the machining cost. So machining cost is going to calculate by using, that is, we need to find out first volume of the material required. What volume of the material removed from the given bar stock. So volume of material removed is nothing but, we can take it as volume of actual taken the bar stock, we can say actual of volume of bar stock minus of volume of the finished component. So that is the total material which is removed from the surface of the bar stock. So volume of bar stock minus volume of the finished component, we will be getting the how much material is removed. Volume of material is removed, we can calculate. So here we know that the volume of bar stock, which is going to be calculated as 106 centimeter cube. Then we need to find out the volume of the finished component. So volume of the finished component, if you take, so it is pi r square by the diameters are given. So pi d square, because here if you look at pi d square by 4, that is, this is the volume of bar, which is all are cylindrical objects. So I can, this is also 15 mm, this is also 15 mm. Okay, so this is the twice of this. We can take this pi d square by 4 into h. So d is the 1.5 centimeter, length is going to be 20, so 2 times of this and plus this cylindrical volume, that is diameter of 30 and length of 60. So by using that, pi by 4 into 2 times of, I can take it as 2 times of pi by 4 into d is, the diameter is 1.5 square into length is 2 centimeters. So we can take it as like this. So this 2 times of I have taken, then plus the major one, that is pi by 4 into d is the 30 mm, so 3 square into h is going to be how much, 6 centimeter. So this, by using this, I'll be getting around 56.5 centimeter cube as the volume of the material required. So now, if you take this, he has given that machining cost is given, right? That is 0.20 paise per centimeter cube. That is, I want to find out the so machining cost is equal to, how we are going to find out here, the is given as that machining cost is equal to, is given as 0.2 rupees 0.2 per centimeter cube of the material removed. So how much of the volume you have removed? So total machining cost, we can take it as, machining cost is taken as 0.2 into 56.5. This is the volume of the material removed per centimeter, per 1 centimeter cube. It is 0.2 paise and 0.2 rupees. And then for the 56.5 centimeter cube, how much it cost? It is rupees 11.3 rupees 11.3. So this is the machining labor charges also, that is overhead charges. This is the machining cost, means this is nothing but the labor cost. This is nothing but labor cost, because he is the one who is going to do the machining operation. So that is why it is taken into as labor cost. How much material is removed, for that he is going to get a amount of 11.3 rupees as a labor cost. So overhead charges is taken as 50% of labor cost. That is 0.5 into 11.3, which is going to be around 5.65 rupees. 5.65, 2 paisa, 2 6, yeah, 5.65. So then this is the overhead charges which I got. Now total manufacturing cost we need to find out. So the total manufacturing cost for one component we need to find out. This is for one component we have calculated. What are those we have calculated? One is first material cost we have calculated. And the second one we have calculated the machining cost, means how much metal is removed, and then what is the cost of that, is labor cost we have found out. And finally we have found out the overhead charges in order to making a component. So these are the three costs involved in making that component. So now I can take manufacturing cost for one piece, because we are calculating for this one piece. So material cost is taken as around 6.785 rupees. Then the labor charge is taken as 11.3. Then plus we can take this as the overhead charges, which is 5.65 rupees. So total cost is going to be rupees. If I add these three, I'll be getting around 23.73. So this is the manufacturing cost per one piece. So if I want to make for 100 pieces, so cost of making 100 pieces, because it's asking to make 100 pieces. So 23.73 into 100, it gives the 2000 rupees. 2373 rupees is going to be the amount which is required to make those number of components. So with this I'll stop today.